It is 1:30, therefore we need to get this show on the road as such. Our first presenter today will be Geoff Bunza, who along with three of his friends have developed what some people I'm not sure thought could be done, a steam proto throttle, and one amazingly enough that doesn't really require equipment that you don't possibly already have connect to your railroad. Geoff?
Hi, and thank you, Geoff. Let's see, I gotta make sure. This might not work yet. Hang on. All right. Okay, try it now. Everybody hear me? We're okay? Yeah. Okay, so there is a short, very short background story with this. This is not just my creation, and in fact, it is a ongoing project that was started in 2019 by the original idea came up Michael Tondi, who's actually on Zoom, I believe. Yeah, in the bottom there, and he was talking with Neil Erickson on the bottom, and about a prototype steam throttle that Joe Fugate had postulated. Well, we got a diesel one, so where's the steam one, right? And the steam one had a discussion. It lost me about in the third page. They were going off and building a simulator for train loads and different kinds of loads on different steam engines. And I wasn't personally particularly interested in it. Michael stayed with it a lot longer. I think Dave monitored it. And eventually Michael said, well, we want something a little different. And he started talking to Neil rather, about what might be an alternative, and got Dave Merrill involved and interested. And somewhere in the middle of the two discussions, I came up with something I had been working on, which was a steam gauge. And I didn't know whether or not I could come up with a steam gauge and make it look like a steam gauge. And that took about, I don't know, a couple of weeks to figure that one out, and put it out to both of the discussions. Of course, it got ignored on the prototype steam gauge that originally started. So Michael and Neil and Dave and I started talking about, could this be done and what would be the parameters of it? And that's where this team got started. It got christened the Amigos by Michael, and away we went. And Michael's original post, I went back and looked at it, was in 2019. And so through the pandemic, we were talking back and forth. We had our gaps in the discussion. And then one fall, Dave Merrill, in his generosity and wisdom, decided he was going to 3D print the case that you have in front of you here. And all of a sudden, it became interesting. And he not only went with the case, but he went and took a design I had for what I was calling a simple Wi-Fi throttle a couple of years before, and he went and started cobbling things together, and away we went. So the Amigos keyed off of that. They put, I don't know how, originally 4 prototypes together and sent them to us as a Christmas present. So we all wound up with the same thing, with the same problems, with the same headaches, with the same issues that we had to develop, which we did. So I don't remember when we actually announced it and put out the article, but we did. So this is the group that started it all. This is the group that's still working on it. And one of the things that makes this different is that we wanted to have fun, just plain fun. And not one of us knew how to operate a steam locomotive. And that became an interesting problem. And I will try to explain the interesting part of that through the discussion today. But last night, we just concluded a 2-hour Zoom with a steam locomotive hostler on the Durango and Silverton. We got an education. And like I used to say about my PhD, you go on and you learn more and more about less and less. and you realize how much you don't know. And every time I've sat and talked with another modeler, I realize how much they don't know. So we were trying to put together what Michael Tondi christened an immersive experience, operating a throttle, but being in the cab of a locomotive. Now, I was very fortunate to have 2 cab rides in steam locomotives. I think Dave had at least one, if I remember right, maybe more than that. And it is not the same as listening to the sounds of a steam decoder in a locomotive going by on your layout. Sorry, but it isn't. It's like not at all. And every time I talk to a prototype engineer or fireman, they go, well, of course. Like it's the most obvious thing in the world, except to a modeler. So we're learning a lot as we go. And I realize how much we don't know. So what I'm going to show you is actually version 2 of what we came up with in combination of the team of 4 amigos. And I'll comment on a little bit about where we might go next before the end of this. Okay? So this is based on a little box that I call the simplified Wi-Fi throttle that I built a while ago. And the whole idea of it was not to build a substitute throttle for your NCE system or anything else. It was to build a throttle for a guest or a child. So you had a minimum amount of controls on it, and yet you still needed certain fundamentals, like you need to be able to pick an address, you needed to be able to operate certain functions. But the original one actually had no capability to turn the power on the layout. And a whole bunch of other things were missing, all intentional. But I said, look, I provided for all these other things, and I released all the code that went with it and tried to have an explanation for it, and said, you can customize it yourself. About 24 people did. And some of them really customized it to be very elaborate. Lots of capabilities. One guy, Phil, I think in Georgia, I think he was, started really elaborating on it, brought it into his club, and the next guy next to him in the club said, can you build one of those for me? Built it, handed it to the guy. 2 more guys in the club came up, can you build one for me? Before he was done, every single person in the club had one of his throttles, and he put all kinds of additional functions on it compared to the original one I had. And he released all of his data and all of his information. You can build one of his too. They've been built in Europe, in Asia, in Brazil, all over the place, Australia. So they've gotten around, but they're simple. And if I remember right, they cost about $18 and $19 to build the whole thing. So there were lots of interesting things that came of it, but that's what this throttle actually started with, the notion, and really the electronics. That's the entire electronics in the throttle. In fact, that's more than most of the original electronics in the throttle. That has a lot of options that were thrown in it. The original one didn't have very much. You can see that when we went and started with this, we then went to that. And one of the things that happened with this, and it uses the same basic the processor and Wi-Fi interface that the original one does. We also gave you an option to use a second one, but it used almost every available connection to it that you could invent. In fact, this throttle here in front of it actually has 2 spare switches that you can use and set to virtually anything you want. And I'll talk about why you might want that later. So we tried to put as much as we could into it. But the interesting thing is there's no special boards. There's no special connections. And everything here you can buy off the shelf. In fact, we give you the URLs to everything that you wanted to put into it. So it's all point-to-point soldering. And a lot of modelers have some soldering experience, some not, some more than others. So you can actually go and buy commercial components and build this, right? And can put it all together. You can also see picture on the bottom of it there, but I'll get to that a little bit later. These are all the parts to go and do it. And you notice a lot of the black pieces Those are all 3D printed parts that Dave Merrill is responsible for. He created all the parts. Now, couldn't let Dave have all the glory printing parts, so I took and tried to replicate 2 of his. It only took me about 2 weeks to replicate 1 part because I had never done any 3D printing before at all, right?
That's not bad, actually.
But it's not bad. By the way, it all goes together with just, a screwdriver. And it's kind of, well, you got to solder the whole thing together, but all the parts are pretty straightforward and all the parts are cheap. There's nothing special. The most expensive part is probably the little green board. And I think that runs about $9 and change, right? If you put all the parts together, we estimated that if you commercially got the everything together, it would probably cost you a little bit under $60, maybe $58, something like that, depending on what you had in your kit box. But those are all the parts to build it. You also note that they're all labeled. There is a detailed instruction set in the article, step by step, with lots of pictures, thanks to the 4 guys, about how to put it all together. The neat thing to me is that a lot of the elaborate stuff that the other group building, the alternative prototype steam throttle, they were looking at brass Johnson bars and throttle levers that actually worked. Well, ours are plastic and the clamps don't clamp, but they look right. And they're actually detents along the way. And you guys can come up and operate the throttle later if you like. But there's enough there. Again, our goal was to immerse you in the cab experience so that you got a little bit of a feel for what it was like being in the cab. Step-by-step instructions are provided. Everything you need to build a working throttle, and in fact, I think about 6 of them have been built by other people now. Everything you need to go and build it is put together. Believe it or not, part of the immersive experience, this thing plays background sounds. So when you're rolling along with your throttle, the background sounds are not the whistle and the bell. They're the rattle of the deck plate. They're blowdowns, water and steam blowdowns. They're water injectors. They're shoveling coal. Sorry for you guys that have oil fired. However, we'll talk about that later. You've got lots of different options, but all these things are relatively unobtrusive. All the design files for all the 3D parts are made available. In fact, they're already online in, I think, 4 different places, Dave? Something like that? About 4 different places. And Dave has kindly volunteered his grandson, who will make all the parts for you for a very nominal fee, right? He's not making a great deal off of it, so don't think that, we're trying to promote this. You can send the parts to Shapeways. You can send them to a local, friend if you want to. You can try making them yourself. Like I said, it's an experience. But all the design work is done, right? You've got to run the machine to print them out, or you got to send them to somebody else or convince somebody else to go and print them for you, right? It's not that hard, right? It takes time. It's much more elaborate than the simple throttle, but it can be done, right? And it's actually, I thought of it as a really neat way of trying out 3D printing for the first time, because they're not HO scale parts or N scale or S or O scale. They're not tiny little parts. They're the parts to make this. So you can actually look at them and say, oh, that's the part. I get it. I know where that goes. I know what it needs to look like. And that's pretty cool. So I thought of it as a really neat way to get involved in 3D printing for the first time. The inside wiring is all point to point. It's all pretty straightforward. Now, this is actually partway done. And Dave, in his wisdom, actually provided, let's see, do I have a laser? Yeah. Right over here under this bundle, there's actually a little plastic loop that you can tie all the wires together and around so that they're all bunched up that go from this part the back of the, let's see, this is the front of the case to the back of the case. So after you do all the wiring, you can tidy it all up. So Dave put in a lot of forethought, in my opinion. Is he flushing on screen yet? Dave put in a lot of forethought on this about how it went together. And in fact, I want to go back to one more. See this thing over here?
Yeah, what is that? Assembly bracket?
That's the cradle to hold all the big pieces as you put it together. He 3D printed that because it makes it a lot easier to put it all together. So
Thank you.
there's a lot of things that have been done like that, one way or the other. And when you actually get the whole thing together, you start looking at these things. And these are the gauges on the front. So what you've got is a steam pressure gauge, which by the way, the other guys don't have. And a water sight glass, which by the way, the other guys don't have. And we thought that was really important because when I was riding in steam locomotive, the thing that both the engineer and the fireman did was constantly pay attention to the pressure gauge and the water sight glass. Now, it turns out we left out one thing, and I'll get to that a little bit later. There's a third thing they paid attention to, too. Anybody want to guess what it is?
Air pressure.
The air pressure gauge. But we didn't have that, okay? So this is what they look like. And we also provided a little tiny display at the bottom over here. It's pretty unobtrusive. And Michael keeps reminding us that we used up the space for his firebox doors with the red light flickering. And he's still lobbying to this day to put the firebox back in.
Need a little bit longer case.
Yeah. So, maybe we'll get around to that. By the way, everybody is lobbying for different ads among the four amigos. So I'll try to address a little bit of that later on. So the steam gauge is here. I mentioned, I think at the start, that last night we had a Zoom meeting with a prototype steam locomotive hostler. He sees the gauge and sees the little tiny symbol at the bottom, which I can't remember. Do you guys remember what company it was for? Was it Henderson or something like that? I can't remember. I can't remember what the company was, but that's the company that makes the steam pressure gauge that I copied. That's the actual face of a steam pressure gauge that I went and then took in and edited the hell out of to make it look pretty when it was reduced to this size, right? Because you can see it's actually not that big. It's about 1.25 inches across, right? The water sight glass was a lot easier, and it was based on all the pictures and videos that I had seen of water sight glasses. So it actually behaves like a water sight glass. The steam pressure gauge behaves like a steam pressure gauge. And we'll talk a little bit about what that means before. But on the information display, it tells you I'm trying to connect to a Wi-Fi server to make the connection. You can set the address up to 4 digits of a long address. And it also tells you what functions you have turned on the DCC throttle. So this is for the headlight, the bell, the whistle. What's M? M is mute. S is what's S? What is S, guys? I don't remember.
Spare.
Oh, S is spare. Thank you.
Yeah, it's a spare right now.
Yeah, D is dim and C is the is that the injector? No, it's the blowdown, isn't it? C is blowdown? I think that's what it is. I can't remember. But those are all the functions that are tied into controls or DCC functions in the throttle. Together, it will display, once you finally get it going, it'll display the loco address that you're controlling and the current speed and the direction. And we'll talk about that in a second. This also is the actual third gauge. Anybody want to know what that is?
Battery.
Nope. prototype steam throttle.
Johnson bar location.
Nope. Johnson bar is right here. You know exactly where it's pointing.
Get the throttle on the thing.
It's the water level in the tender. Right?
Ah.
Now, why is the water level in the tender important? Well, because this is an operating steam throttle. That's why. So we'll get to that. Here's all the controls all over it. It has 4 AA batteries in the back, as does this one. There's a switch to turn it on and off. There's something we call auto fireman, or sometimes I label Fireman Fred. There is a story behind that. And as we've gotten to learn about how to operate a steam locomotive more and more, I can't remember, it was Michael or somebody last night said, as we're 2 hours into discussing operations on a steam locomotive, somebody paused and said, you know, this is a lot of work. You got to pay attention to like 5 different things at once. Otherwise, this thing ain't going anywhere, or it's going to do bad things. Well, guess what? We're approaching that. And as so, remember, I said before, we approach this as, if this isn't fun, why the heck are we doing it? Well, that switch for automatic firemen takes away all of the quote unquote work. And it will always keep the water at the light level. It will always keep it fueled. So you can just work the throttle and brake and whatever else. And you don't have to pay attention to all that. Now, you can also pay attention to all that and run out of fuel. And I think Dave was at some group meeting, and he gave it to a prototype engineer and walked away. And the guy was operating with it. Dave came back and he looks at Dave and he said, I ran out of fuel. Why did I run out of fuel? And Dave looked at him and said, because you're supposed to run out of fuel if you don't fuel the engine. And he said, oh. So you wind up with the reality of running the engine, and it hits you straight in the face. Over here, you see all the other functions you've got. Here's the water injector to put water into the boiler. The button to shovel coal. Now, this version assumes it's a coal-fired engine. There's the headlight switch, the bell switch, the mute. Now, the mute sends a mute to the DCC decoder, but it also turns off all the background sounds in the throttle, thinking that we might drive you crazy at some point, just like it may be too much work. So you have the ability to shut it all off, shut off all the sounds. And there's a spare switch over here. Let's see. The short whistle got changed. I'm trying to see what else. The Johnson bar is on the side over here. This is the back of the unit. So the Johnson bar is here on the side, and on the top is the throttle. And that's all the functions we've got right now. Now, the throttle just doesn't make it go and slow it down. The throttle interacts with the Johnson bar. And if you don't know what a Johnson bar is, it's not just a direction switch. The Johnson bar controls the amount of steam into the cylinders. When you control the amount of steam into the cylinders, you're effectively controlling the power behind the cylinders. And as we found out in our educational course last night, it's an interesting way to start the engine. It's not what I thought it was, right? When you start the engine, you put the maximum steam into the cylinders and you push the throttle in, and it's barely going to turn. And as soon as you start to get the engine moving, you pull back on the Johnson bar. And the faster it goes, you're pulling back on the Johnson bar, limiting the amount of steam in the cylinders as it's going faster and faster. Why? Because it doesn't need all that steam, right? So the engineer is actually operating the steam locomotive, conserving fuel and steam as he's going along. Not obvious to the guy just turning a knob on his throttle, right? Also, consequently, when you've got the Johnson bar pushed either full forward or full reverse, it turns out you're using up a lot more steam because some of it is not doing useful things. that's going out the stack. Therefore, we infer from the use of steam, not just where the Johnson bar is and everything, but also how fast you're using steam, fuel, and water. Okay, so what we're inferring from that is that these are slowly declining depending on the setting of the Johnson bar. Make sense? Use more steam, you're going to use up more power, you're going to use up more water, you're going to use up more fuel, right? It turns out that that balance, and what we heard last night was a balancing act in the most magnificent way possible. And the fireman is directly involved with that as well as the engineer. But the fireman is worrying about different things. All these things come to operate the steam locomotive. I have never heard that conversation with modelers, ever, right? So one of the things that when we started gathering up this information, and I put out on the MRH forum, if anybody's ever operated a steam locomotive, can you write and share your experiences, particularly the sights and sounds in the cab? Now remember, this sort of looks like the backhead of a steam locomotive, and we're trying to, as Mike put it, we're trying to immerse you into the cab. We're trying to recreate some of that feeling to make it a more fun experience of actually operating your steam locomotive. That's what we're trying to do. The fireman, as we found out, isn't just, if he's got a coal-fired engine and he's got a shovel, if it's a small enough engine, then when he opens the doors to the firebox and he puts the coal in, he just doesn't throw it in. He's being very careful about how it's distributed on the grate, right? Now you'd say, well, big deal. He puts a little here, he puts a little there, he puts a little there. Well, it turns out the most efficient way to fire a steam locomotive is with the minimum amount of coal to make the heat, with the coal and fire evenly distributed across the entire grate. Who would have thunk? Now, having been taught that, most obvious thing in the world to me. However, I never thought of it before, never had to, never been put in that position. The really interesting thing came when we started to learn about what the fireman does with a mechanical stoker. And we started being modelers. We started, and by the way, the guy we were talking to was not a modeler. And he was very gracious with his time, you know, and given the fact we basically knew nothing. We started using the term automatic stoker. How many times have you heard automatic stoker? Bullshit. No such thing as automatic stoker. Mechanical stoker controlled by the fireman. And how does he control it? With steam jets. Never heard of such a thing. You ever look on the fireman's side of the cab and there's this row of valves? He's controlling, among a bunch of things, the steam jets to the mechanical stoker output. So the mechanical stoker is this big auger from the tender, bringing the coal up to the firebox. And just like the fireman would distribute the coal among the grate to make it even, the way it's distributed with a mechanical stoker is the fireman will turn on the steam jet, and there are these channels in the firebox that the steam jet shoots the coal into different places in the firebox. Now, the ones that he's fired typically have 5 steam jets. So there's 5 valves. He said on a larger locomotive, there could be even 6 or more. So what you do is you control the steam jets as the stoker is putting the coal in, and it's blowing them into the different areas of the grate to distribute them evenly. Who would have thought? I had no knowledge of that whatsoever, right? So we're trying to figure out now, well, how do you do that? What does it sound like? You know, what do you have to do to put it in, and how do you control that? You know, we're looking at it from the standpoint of how do we figure it into the experience of being in the cab? Now, there's only one guy holding the throttle, right? And I'm not about to build tandem, even though Dave might one day. Dave, you're going to build a tandem cab on me? One for the engineer, one for the fireman. But right now we've got one, and we don't have a fireman position. Although we do have a bell pull, and the bell pull typically is pulled by the firemen. But the whole issue we've got is how do all these things interact to make for an even better experience? And that's what we're all about. That's what we're trying to do. And in the process, since we're trying to gather what I personally consider rare information, we're also going to try to build a bibliography and maybe some videos and maybe some audio of the people that we've talked to so that other modelers can go spend a couple of thousand hours absorbing it all. But I wasn't able to find one location that had even a fraction of what we wanted. And our friend Bruce, the hostler in the DNS, actually did the most amazing thing. If you go on YouTube, you can find videos of being in a cab of a steam locomotive, but you have no idea what the sounds are. He actually went in the cab when he was moving one of the locomotives, and he said, okay, I'm about to turn on the valve for the water injector. He'd video him turning on the valve for the water injector, and we'd see and hear the sound of the water injector, right? Then I'm going to go and do this. I'm going to operate the blowdown. Here's what here's where it is. Here's what it sounds like. So we had short snippets with sounds that were specific to appliances on the locomotive. That was really cool. That was exactly what we wanted and exactly what I couldn't find. So we're trying to work with him to see if he could get us some more of these. And he's been very, very cooperative. His dad was an engineer for the Canadian Pacific Railway and just a great guy. But one of the most enthusiastic steam people I've ever met in my life. Just an amazing person. Okay. So there are things here like the position of the Johnson bar controls the steam flow into the cylinders. It's going to affect the ramp up in acceleration, deceleration, consume, how much steam you consume, how much water you consume, how much fuel you consume. Well, in all honesty, you might look at the code and you might say, well, the computations you've got look really complicated. They're trivial. If you go and look at the other group building the other prototype steam throttle, they are trying to model the load per car of the train and how it affects the steam engine, right? We ain't nowhere near that, right? We're just trying to get sort of a cause and effect. You know, you push the engine too hard, you use too much steam, you use a lot of fuel, you know, the water level goes down. And I actually ought to do that now. Because I wanted to demonstrate, in fact, that you can run out of water, you can run out of steam, but it takes a while. It's not like instantaneous. And when I sat down to try to do the computation relative to the prototype, the thing that I was worried about was, you can see it powering up. It's going to make a connect. Where's this? Oh, where do I point this?
At the camera that's right there.
Right here? Yeah, that guy.
Well, you don't know how much you're gonna see.
Okay. So as it goes through, it powers up, it looks for the Wi-Fi connection, and there's a little message on the steam throttle connecting to Wi-Fi. There's several messages on the bottom as it steps through each one. And eventually it powers up, makes the connection, and you're ready to go. Now, when I powered this up, you notice I'm using a little tiny Arduino as a DCC controller, using something called DCC-EX over here. And by the way, it's 12-volt battery powered because I didn't want to fool with the connection. But you notice that nothing's happening with the engine. Well, the reason for it is power isn't turned on the DCC controller. So we have a cute little thing where if you put the 3 switches up, right, magically make your incantation over here and then turn it on, it goes through the steps of the power on and then turns the power on. I don't like what it did. I know what the sequence is, so I'm looking for a particular thing that happened. Okay, we power up. Power goes on. That's the right thing. So I can turn the bell on and off. I can blow the whistle. Now, Dave was using, let's see, can't remember which DCC decoder it was, but his DCC decoder had a function for a short whistle and a long whistle. And we were going to use up another switch to do a short whistle, and I didn't like that. So what we did instead was this. Well, if you just pull it down very, very quick and let it go, you get the short whistle. If you hold it down, you get the long whistle. And that's actually changing the commands that are going to the DCC decoder. So that was all programmed in. And then the bell is just a switch that you can turn on and off. And the other thing you could come up and play with it later. Yes, I will let you play with it. You'll probably break it. It starts at about 225 pounds of steam pressure. The water sight glass is about 90% filled. And if you let it run, and I've got a Johnson bar all the way full forward in this particular case, and if I just barely let it go forward, and then to reverse it, I'll put the Johnson bar forward, which is the way it typically is, and then put the throttle in place, and hopefully it does its thing. Now, if I just leave it on, which is what I'm going to do, even though it's just idling there, it's still going to be consuming fuel and water and steam. And what's going to happen is we're going to watch and see the steam pressure gauge. Hopefully you can see that. The steam pressure gauge is going to go down, and eventually it'll run out of steam if I don't do anything, because I don't have Fireman Fred engaged in the back. Also, the water level will go down for exactly the same reason. So how do you deal with that? Well, for the water, you push the button that says turn on the ejector, and it adds water to the boiler, and the sight level starts to rise. If you are running out of fuel and the steam is going down, then you push the other little handle in the front, and you'll hear. If I do this. You'll hear the sound of troubling coal. If I push the other one, that's the water injector putting water into the boiler. So the sounds are local here. And then if I just leave it alone for a while, what you find is I start to get background sounds. What are the background sounds? They're hisses, they're rattles, they're little bumps in the night. They're the tender apron rattling, bouncing up and down as you go, which only happens when the engine is moving. So you've got these other background sounds typical to a cab, not typical to the engine rolling by as you're looking from the track level. So there's a whole different set of sounds and everything else that go with that. Okay, so I'm going to leave it like that. And Fireman Fred is not on duty today. So the pressure is going to go down gradually. The water is going to go down gradually, even at idle. If we had pushed the throttle full forward and we had the Johnson bar fully engaged, which I think is called being in the corner, the rate of use of pressure and water would go up considerably. I can't remember if it's 4 or 5 times as much. You can ask Dave later, because he's on the call too. So all of those things interact, and that was the whole point. If I could get back to my screen. Okay, all of those things interact. And if you run out of steam, you run out of water, well, particularly if you run out of steam, the engine stops. So as the amount of fuel and pressure is going down, the engine's slowing down, and eventually it's going to stop. And the only way to get it to go again is to refuel it, put more water back in, and then it'll start to move again. So when I said it's worked, yeah, it is, unless you turn Fireman Fred on, give him a couple of bucks for the day, and he'll do all the fueling and water tending for you.
As needed, or is it all
As needed.
programmed to
Keep it up.
determine when it has to?
Yeah, you'll see it drop a little bit, and then when it gets to a certain threshold, it'll go back up again. That's Fireman Fred doing his job.
So is the coal feed based on shoveling, or is it an?
Shoveling,
It is.
yeah, it's based on
Not
shoveling.
an automatic feed.
No, but hold that question for a little bit, okay? So, any questions about the interaction or anything?
My question is, the sounds I'm hearing, are they coming from the throttle or are they coming from the local?
Loco. The ones you'll hear from the throttle aren't like this at all.
Okay.
By the way, remember I said I can turn it all off? I can send a mute. I can turn the sounds off from this and sounds off from the locomotive, right?
But when you move it,
It mutes both, right? Now, on your throttle, you can make it mute one or the other. And this third one over here is a spare, and you can make this one mute the locomotive and this one mute the throttle,
Okay.
right? So we thought about that, and we thought that, well, just because we have it this way doesn't mean everybody's gonna have it that way or want it that way. There's also a spare switch in the back. So there's 2 spares that Dave, in his wisdom, by the way, put in the throttle, and for darn good reason. And the interesting thing is, we've used both of them and then taken them away. Depending on us coming up with other ways of doing stuff. Yeah.
Absolutely blown away. I'm thoroughly amazed. But I do have one question. There's one more thing from the cab. You have sand.
We don't have a sander,
Okay.
and we haven't even talked to our hostler about the sanding unit yet, right? And I thought about it after we ended the Zoom meeting last night.
Fuel last property, so it's.
Yeah.
So it sounds to me like we could theoretically run the locomotive with just the Johnson bar and you don't need the throttle. I'm talking about the real locomotive, not this.
You still need the throttle, because it's still controlling the amount of steam to the cylinder.
So both the throttle and the Johnson bar control these.
Yeah, and they're different valves, and I don't remember which one is which.
It's
Right.
kind of like voltage and amperage. The Johnson bar, I think, is your amperage. It's how big the hole the steam can go in is. And the throttle is your voltage. It's how much steam you're gonna get going towards that hole.
Okay,
When I tried to describe how we thought about it to our hostler last night, he corrected me and said, well, it's not really steam, it's power. The Johnson bar is controlling the amount of power to the cylinders. That's the way he thought about it. And it wasn't the way we thought about it. So I'm still trying to resolve that. It's probably going to require another conversation, but
I'm starting to understand. Oh, thank you.
I'm way down on the bottom of the learning curve, right? I'm freely admitting it, guys. I don't know. But it's just more and more fun as it goes.
So it's designed or programmed so that as you operate both of those, they have to synchronize or
They interact.
they interact.
They interact. And that I never thought of before. You know, I'm the guy, cranking the knob, on his MRC controller 30 years ago. That's my idea of a throttle.
Yeah.
Right? This is way beyond that. This, like I said, if you don't have Fireman Fred engaged, this requires work. Right? And you got to think about what you're doing. So, Michael was right. This is an immersive experience, and we've only scratched the surface of it. I'll give you an example that I just love. When I originally created my example for the steam throttle, one of the things I did was put random jitter in the needle, right? And then I took it away because of the way we calculated where the needle ought to be, right? We had about a 20-minute discussion last night about the jitter and changes in the water sight glass. Why would that be? Well, for starters, just by operating a locomotive and moving it across the tracks, there's a lot of bounce and jitter and everything else. That affects the water sight glass. So the water sight glass is doing one of these as you're operating the locomotive.
Your water level is being slosh back and forth.
Right. Now, remember, there's no electronics here. This is all mechanical, right? And he's got a little sight glass. That's where the water is, right? Now, the other interesting thing, where is he measuring? Where's the water sight glass measuring? Is it in the middle of the boiler? No. Why is it not in the middle of the boiler? Where's the most important place for the water?
Crown sheet.
Over the crown sheet. Because if you don't have enough water on the crown sheet, guess what happens?
Boom.
It goes boom. Now, we actually had several discussions about whether we're going to make it go boom.
And you should.
And we decided that that was uncouth. However, I'm sure we're going to have another discussion about making it go boom before this is all over. Right? Now, the interesting thing, though, is as you're operating the locomotive, the water sight glass level, the level there is bouncing around. So my question was, well, how do you know where it really is? And he said, well, that's what you get trained for. You've got to figure that out. And so you can't just glance at it, see where the water level is. You got to stare at it for a while, pay attention, and then in your mind, you got to average it out, high and low. And then somewhere in the middle is going to be where it really is. And I said, oh, okay, pretty simple. And he said, no, not simple. What happens when you enter a grade and you're going up? Well, guess what happens to the water sight glass? It gets filled up. It goes nearly to the top, right? Well, that's really interesting. How the hell do you know how much water is in the boiler? He said, you got to know. You got to know where you started before you entered the grade. And then you come to the top of the grade, and what happens? It goes back down again. So now you're back trying to measure how much steam you use, where the water is really now. But what happens if you're on a hill and you got to the top of the hill, you were going up and up the hill? He's talking about a 2.5% grade on the DNS. Now you're going down a 2.5% grade. What does the sight glass look like? It's way down on the bottom. It's not to the zero, but it's way down on the bottom. And now you got to worry because it's actually telling you how much water is above the crown sheet. Right? So the fireman's job is to make sure it doesn't go boom. Right? Because the engineer's got all kinds of other problems we haven't even talked about yet that he's worrying about. So this is the set of problems. And to me, it's like, I can do everything except account for a grade with the water sight glass. I can jiggle it. I can make it do all kinds of weird things. And so 10 minutes after our Zoom meeting last night, I'm thinking about how do I put a sensor in the locomotive to tell what the tilt is that feeds back somehow to the throttle, and that's kind of how this whole thing with the Four Amigos has evolved. Somebody comes up with an idea. I wonder if we could do this. How do you make that happen? And then there's a discussion and it gets elaborate, and then maybe we throw it out or we bring it back, the following week. Those are the kinds of things going on, right? So the water sight glass actually jiggles around and it tells you a lot, or can tell you a lot, but it also can hide things from what's actually going on. Who would have known? Right? I didn't know. Sorry. I had 2 cab rides and I still didn't know. Never paid attention to it. I saw that the fireman was paying attention to the water glass a lot. I know he was making adjustments. Another thing with water. Okay. Water's going down, making steam, steam's blowing out the chimney, right? What do? You turn on the injector, put more water into the boiler. What happens? What? The pressure goes down. Why the hell does the pressure go down? I'm helping it.
It's cold water.
It's cold water.
Cooling it off.
So you're cooling off the boiler. So I said, oh my God, so what happens if you just left it on? He says, you don't have much pressure after a while. So then the question is, how much do you turn it on? Right?
The training school.
Right? And I'm figuring, well, he timed it. He's got some flow meter somewhere. Oh,
So experience.
you look at the steam gauge. If it drops 15 pounds, you're done. Because now you've got to let it heat back up to recover the 15 pounds. You let it go to 20, you're teetering on the brink of making complications because it's got to heat the steam back up, and you, the engineer, may want to call on for more power. If he doesn't have the steam pressure up to where he wants it, you're in a lot of trouble. So the fireman and engineer are working cooperatively, and they're talking to one another and saying, okay, if the engineer may call on, you can put the water on now, we're good, we're on the level for the next 3 miles. They're talking back and forth, right? So they're cooperating to operate the locomotive. Okay, when was the last time you heard a modeler talk about that? Right? Doesn't happen. But you have all these complications. Some of them are fun to deal with. Some of them are, you just make the water glass jiggle. I know how to do that, right? That's not going to, do anything really terribly complicated. And some of them, you got to make sure that when you program all this stuff in, Fireman Fred is there to bail you out at the right time, right? So that's where this stuff is. These are among the complications and the interactions. That's not the end of it.
What about the water level in the tender? Is that all visual observation?
When you start the injector, it's putting water into the locomotive boiler. It's also drawing down from the tender.
Yeah.
And so if you keep putting a lot of water into the boiler, you'll see the little gauge on the bottom that I said was the tender level.
Yeah.
It goes down to
So
zero.
that does monitor.
Oh, yeah. Yeah. And the way they actually do it is with a stick. They'll open up the tender hatch, they'll stick a stick down, and they'll see what the water level is.
Now
So
we've
they're
got-
not doing it continuously, and it's a matter of judgment and operating experience. How much they're calling on for water in the boiler and how big the tender is. And lots of different size tenders,
Yeah.
right? So again, it's an interaction that nobody talks about.
It's an observation. You have to go out and look. To see
Yeah.
what-
Now, we didn't think people want to go climb on their tender and look, so we have a little gauge, right, just to make it fun.
What about the cold? Is that, you don't have anything to monitor the cold?
We assume you have an infinite supply of coal.
That's gonna be version 2.
No, this is version 2. That might be version 3.
A little button to add, reload, refuel.
So the way this actually operates, once you get to deal with the throttle bar and the Johnson bar, it connects to a command station with a Wi-Fi interconnect. Now, originally, this was defined by a group called JMRI, Java Model Railroad Interface. Some of you may use it to program decoders. It's a lot more than that. But they have a Wi-Fi server that'll allow you to connect a cell phone throttle, this throttle, my little simplified throttle, and it'll connect to any of these. And the reason it will is the communications protocol, we're going to talk about next slide, is standardized by JMRI, and other people have picked it up. So you can go to JMRI through your home router or access point, and then connect to a DCC station. You can use the Digitrax LNWI, uses the same protocol. JMRI on a Raspberry Pi, same protocol. You can see this over here. It's nearly exactly what I have in front of you. And I have this little thing called SOX, which basically miniaturizes a DCC base station and puts it inside a steam locomotive or diesel. And I demonstrated that a couple of times back. So because we use a standardized communication, you can connect to any of these that support the standard protocol. And this is all based on the JMRI protocol. Whoops. The JMRI protocol, wherever it is here. And these are the commands. This is an eye test, but there's a whole bunch of different things. But all of these commands are not programming throttles. They are commanding throttles. They're setting speed, turning on functions on and off, things like that. So it's a subset of the DCC command set in effect. And anybody that uses that protocol set forth by JMRI, we can connect to it. And there are more and more of these things coming on each year. We set out to make this a fun thing. We knew that we weren't going to come up with the be all and end all. So this is actually documented to allow you to go and make some edits and change the parameters. If you think that the drawdown of fuel and water ought to be higher rate, you can go and change that, right? If you don't want any of that, you can go and change that. What you connect to in terms of your Wi-Fi, you can go and change that. You don't have to adopt virtually anything we've got. And we're also around to help you. Like I said, I think there are 6 or 8 other throttles that other modelers have already built. Because some guys just went crazy for this. But, as they say, but wait, there's more. Ginsu nice. One of the things that Neil Erickson had asked us about very early on was, can you make adjustments for the tonnage of the train you're pulling, the grade, the weight, a whole bunch of other things. And it turns out there's one modeler who's moving down that path already. Now he's going to manually put all that stuff in. He also has a battery level gauge that he's provided for. He hasn't released his stuff yet. We're trying to get him to publish it. But those are the kinds of things that you can add relatively easily. In fact, he didn't think that the water sight glass was worth anything. So he eliminated it. And he's got this massive steam gauge on his throttle. There's one big steam gauge. And it's pretty big. It takes up the whole throttle face. So there are things that you can customize this with. And being naturally clever people, the amigos are not the only ones who can think of new things to add. And in fact, for the first time ever here today, thanks to the work of Dave Merrill there, you'll see that the 2 throttles on the right are a little different. Now, for one thing, they're taller. The version 2 one, this one here is on your left side, and the other 2 have an added gauge, and that is an air pressure gauge. Now, that face of the air pressure gauge is, again, the face of the prototype air pressure gauge that we went and doctored so that it was clear when it was reduced. It's got a little logo on the bottom, air pressure, or somewhere in the middle. And what we're trying to do is to now integrate how the brake would integrate with the rest of the throttle and the locomotive. So it's not just the air pressure gauge. That red bar in the middle over here, that's actually going to probably wind up being the train brake or the automatic brake. It was pointed out to us that there are, of course, 2 brakes. There is the locomotive brake, sometimes called the independent brake, and there's the train brake, sometimes called the automatic brake. And the automatic brake will turn on both the locomotive brake, the independent brake, and the train brake. Now, again, thinking that we're naturally clever people, we know everything there is to know about railroading and operating prototype steam locomotives. We thought, well, you apply the train brake or the automatic brake and the train stops, right? No, that's not how it works. You put on the automatic brake, you start to put on the automatic brake. What do you think? And then you engage it. There's a name for that. It's notched, like 6 notches. Put in the first notch, then you put it into lap. When it's in lap, you then go and release part of the engine brake. Why? Because if you don't, the brakes on the tires on the locomotive get hot. So what you wind up doing, again, is this coordinated effort of working the locomotive brake or the independent brake together with the train brake. It takes skill to do that. You just don't go and flip a lever and you're done. You know, that's a good way of screwing yourself up together with your train. Also, if you're a passenger train, you're going to shake the passengers up, or if you're a freight train, you're going to shake the cargo up and throw stuff around. You don't want to do that. So the operation of the brake in conjunction with the speed, in conjunction with the air pressure, it all goes together. So we have another problem that we actually already started looking at, given that we were able to combine and come up with a bigger display. And you notice that those are grouped kind of pretty closely together. Well, there's a reason for that. It's actually one display behind it. And all we did was break it up so that it looks like three independent gauges. And they operate and try to convince you like they're three independent gauges, right? That's what's coming next. That's version 3.
There's room for another gauge up there.
What?
There's room for another gauge in there. Be a small one.
Did you hear that, Dave? They say there's a room for another gauge in there.
So when you operate the thumb brake there in the center view, does that just run the train brakes or does it run the
Right now, right now,
brakes?
right now it does neither. Right now, if I flip this all the way over, okay,
Yeah.
it'll put out an emergency stop
Okay.
to the decoder. If I put it to the middle, it sends out the what is it, function 6 or 7? It sets function 6 or 7, which is the brake on some decoders.
Okay.
Right.
7 is
Now, it turns out it's the brake on all decoders that I don't own, but it's still there. Right, so on my throttle, it's disabled. I don't set that thing. But in the normal load, it sets function 7 or 6. And
Actually, it's a position brake. It's not just a little lever that you can apply.
it turns out that that's what we learned. It's a notched lever in
Yeah.
6 positions. And each of them, it turned out, can be labeled. So now we're going, Dave is going back, right, Dave? He's trying to figure out how to duplicate the notches,
Okay.
because they're not all notches.
Yeah.
2 of them are flats. Did you know that? I didn't know that. Learned it last night. You know, another one of these things that I never knew, and convincing me how little I actually know. So somewhere along the way, we'll get all the knowledge. We'll read up on it. We'll try to figure out how it impacts this, how it impacts Fireman Fred, and we'll try to come up with something that looks reasonable. But that's the next version out. And you are the first people to see that other than the Amigos. Just to give you an idea of the size of it, that's version 2, that's this one up here, relative to the diesel proto throttle on the far left. And this is the TCS throttle. And then that small one. Which one is that? The Z21? Yeah, okay, that's the Z21. Yeah. So those are the 3 throttles. And you can also go to that tiny URL, or you can go on the NMRA site and search for Operating Steam Throttle, and you'll find the article that tells you everything you wanted to know. This is the not an eye chart; it's the bill of materials for the throttle. I just wanted you to know that it is contained. It's not like 5,000 sheets long, and all of those are the URLs of where to get the parts.
So this is all accessible on MRA?
Yes. Yep. And all of the additional information, the sketch to program the ESP32, everything's provided, including all of the STL files to do the 3D printing and the step files if you wanted to go and redesign the parts. And when we get to version 3, we'll publish all that as well.
Yeah. This question is actually possibly more for Dave. With 3D printing, do you prefer filament or resin for this?
Dave and I filament.
I use filament. Neil did one in rosin. It
Resin.
works the way.
Okay, so resin will hold up to it.
Yeah, I know of at least 6 filament printers that have been tried and worked, and Neil printed his in resin.
Okay.
So it works in resin too.
Somebody else out there did a resin one also.
Okay,
One of somebody. I can't remember the name.
Thanks, Michael.
that's it, guys. Any questions?
Nate?
Dead rail,
What about dead rail?
well, how compatible, what kind of, I see that you, your signal here goes to a unit that, provide power to the rail.
Shall we go to socks?
See the thing on the bottom?
Okay,
That can operate dead rail with battery carried on board.
He's got an entire DCC base system on a chip.
And you give me a couple.
It'll fit in your guys' room to spare.
I just published another one that's smaller, that doesn't use this protocol, but it'll use, what does it use? Uses a web browser. And that unit will fit inside a N-scale car. And I've got another one coming out that's half the size of that one, that I'm hoping to use the same Wi-Fi protocol as this. That'll fit inside an N-scale car. I actually have a battery that fits in the N-scale car because it only occupies a quarter of an N-scale boxcar.
And your magnet connections are even tinier.
Did that answer your question?
Is that? No. So, I'm just made it's a cool throttle and I love all these functions and, us large scale operators, I could see that as being, a real bonus, and we're all dead rail dudes.
Well, it turns out the last one that I published that was wireless to the locomotive, the original guy that used it was a modeler in France, and he put it into an N-scale switcher. I'm sorry, a G-scale switcher. Had that wrong. And the only reason that he did that and didn't come up with what I came up with is the driver that he had was about yay big and about yay high, right? So I just changed the technology around and went with something that was very flat, much more efficient than what he had used. But his technology was about 6 or 7 years old.
But bottom line is it's real good.
It's doable. It's doable.
But you need a bigger handheld unit because you're,
Any
it's gotta be 2 hands.
other questions?
That's so good.
So this will be around here. Craig's gonna go and regale us about his layout, which is a great layout. So I'll have it operating after so that you can come up and play with it or ask questions. Are there any other questions before we drop? Any questions for the other amigos, Dave and Michael, who have joined us today?
I was going to point out, I believe Neil does dead rail. Does he not?
Yes, he loves the idea.
Doesn't Neil do dead rail
I think so.
on his ON30?
I think so.
Very much
Yeah.
a proponent of it.
So what Neil's after us and has been after me for about 2 years, is Neil wants a way to automatically couple additional cars on his ON30 and figure out what the tonnage behind the locomotive is. Right, well, that's a different kind of problem, right? I may have an answer to it by the end of the year. So, different problem.
So all in, to build this, I didn't pay any attention to the cost, but you mentioned the price right up front.
This for as near as I can tell would cost about $60.
Really the case?
Well, I had a friend do a trial printing he's in Bend, and he said he's not going to charge me. He didn't charge me anything, but he thought he used about $4.50 worth of plastic, and he wasn't going to charge me anything. So go find a friend and have him print it. It's not much. By the way, in case you don't know, there's lots of different kinds of plastics to print this. Dave used a really neat. Dave, what is this plastic called?
PETG. PETG.
PETG, PETG. It's really neat stuff. It's flexible. When we screw the screws in, they're all cap screws to make it look sort of like steampunk. They screw right in. They do self-cutting threads on the plastic. And I found them to be really resilient. I printed on mine, if you look, I'm gonna go back. My collar is a little bit different. I narrowed it down with Dave's help, and then printed it on my borrowed printer from my son, and then colored it with acrylic gold paint to make it look like a brass bezel. And I also did the same with the levers on the Johnson bar and throttle.
They fairly durable?
Nobody's broken them yet. You can't wiggle it very much because it actually has what do you call it? The detents that you would normally pull it and position it to. They came up with a little spring-loaded wedge that it bounces along the detent. So you feel the detents as it goes. And it's absolutely cool, right? I mean, the first time I got into it and grabbed it and started using it, I figured, no big deal, right? You get into it a little more, you forget certain things. Like, I don't know how many times I've grabbed the Johnson bar and thought it was the throttle. And, didn't adjust the speed, but threw it in the reverse instead. And, I've done all kinds of screwball things with it, right? It, like I said, it actually requires thought to operate the steam locomotive. And as we add the other stuff for the brake and the air gauge, it's going to get more complicated. So Fireman Fred is going to be real important to be able to turn it on and make all the work go away. Because there are going to be a whole bunch of people that are going to be enamored with, oh yeah, I want a prototype steam throttle, and I want to be able to calculate load and all this other, fifth order effects. Well, yeah, for the first 10 minutes maybe. But after you determine that it's now a whole bunch of work to run your model train for 10 feet down the track, you may think otherwise, right? So Fireman Fred's going to be an aid to a lot of people, I'm predicting. I know I've used Fireman Fred a lot.
Yeah.
Oh, guess what?
What's water pressure?
It's not turned out, thank
Can you see? It's 0.
It's gone to 0 already?
It's gone to 0 and well, fast clock. Come on, man, fast clock.
Is it a 187 or a 160?
So the water has gone down to 0. Pressure's gone down to 0. If I flip Fireman Fred on, the pressure starts coming up, right? The water starts coming up.
Doing his job.
Okay, now I could also have held down the water injector. I could have held down the stoker, which is the coal shoveler. When I said before that you could customize stuff, one of the things I think is entirely appropriate is to account for the fact that you can have an oil-fired engine. There's no coal noise, right? But there are other noises. And you can have a stoker, and you can have a fireman operate the steam jets to distribute the coal from the stoker. So there are other things you could do, but every option you embed, you've got to figure out a way to let the modeler pick what he wants, right? So from the Amigo's point of view of trying to figure out how to take something complex and make it simple, that becomes our problem, right? But the neat thing from my perspective in many ways is once we solve those problems, at least you have a starting point. You can make it less complicated or more complicated, however you want to go. And it gives you a starting point. I also think, I talked to a friend of mine, he thinks that the ratchets and the lever for the throttle lever and for the Johnson bar can actually entirely be made out of 3D printed parts and still operable. Now, we're not there, and I'm certainly not going to do it, and I'm not even going to ask Dave to do it, because this is just fun enough for me, My big deal is, if it's fun, that's great. I've done what I wanted to do, right? And like with the simple throttle, If you want to take it and you want to make it as complicated as hell, so I have no idea what you're doing, more power to you. That's okay. I don't mind a bit. But we made a decision as a group right from the beginning. Everything we produce, we were going to make available to everybody, gratis.
Yeah.
Nobody's making any money on it. You know, you want to go and make a business building these and then selling them, fine, go and do it. I don't care. Right? It'll take a little bit of doing. I can't remember how long Dave said it takes to wire one up, but he's probably the best of the four of us actually building one from scratch. Because he's done more of them than anybody else has. I'm in the middle of building my V3 with the air pressure gauge right now. But I've got a young grandson, so I'm occupied.
Is there, in your instructions, is there step-to-step instructions?
With pictures,
Of your wiring and how?
with pictures, step by step. I can't remember how many steps there are. There are
Which
30
terminal goes
steps or
where?
something, right?
Hey, Jeff,
Yeah,
there's also a 3D printed soldering jig that you can get that Dave made that holds the parts while you solder them together. I don't think that was in the picture, but there is a little soldering jig.
oh, there's the second one. There's the big one and
Yeah.
there's the other one. Yeah. What Michael's pointing out, remember the big hunky thing? Everybody said, well, what the heck is that? Yeah, well, there's a little blue thing that actually holds the parts so that you can measure the wires accurately before you mount them.
Okay.
So like I said, Dave was damn clever. There's a lot of thought. They put a great deal of thought into this stuff. Right? Oh, there is one little thing that actually there's also a calibrator. There's a piece of software before you load it up with the steam throttle. You load it up and you notice that we've got these levers for the brake, for the Johnson bar, for the throttle. Well, they're all measuring potentiometers, and because they're not going full turn, you have to know where they start and stop. So we have a little program that you load, and all you do is go from end to end, and it displays on the steam gauge, but it doesn't look like the steam gauge, but it displays all the parameters that you just copy and then put it in the program and you're done. So to calibrate it and set it up, there's a little tool that you've got to make it trivially easy for you to go set it up right from the start. So we tried to think of as many things as possible. Generally, when I put out a project, I don't want anybody to do programming. That's not what the hobby's all about. So everything's done, right? Now, if you can edit with an editor, you can change parameters and make it do interesting things for you, change rates and things and stuff like that. If you wanted to, I can even show you how to put a different steam gauge in and how to get it to it. It's a little bit of work, but you can do it. The hostler we had said that we managed to pick one of the most accurate and high quality gauges ever made. And even today, people who are operating steam locomotives try to go and find those gauges. So that was kind of cool, just from that little symbol at the bottom. And I was really proud of that. And it was dumb luck. Just plain dumb luck. But we try to find stuff that is prototypical, that was real, that we can adapt and come up with a fun project. That was our goal. So I hope we succeeded. For some of you, I hope you all try to build one. I know some of you are diesel operators, but it's still a fun project.
I got a shed.
Any other questions?
And
Any
we also
comments?
put
What?
we also put a place for a safety lanyard for you.
Oh, yeah. On the back, I don't know if you could see it, but there's a place to put a lanyard. So if you want to hook it on your fascia or you want to carry it around, you'll find it's incredibly light. I think the heaviest thing in it, in fact, is the batteries. It's 4 AA batteries, right? And they last quite a while. I've got AA lithiums in here. And I don't think I've changed them yet. So they've been on and off fused for a while. Other questions? Thank you for your time. I hope you enjoy it. I hope you enjoy it.
Your whole team, that's an amazing development.
Yeah.
And it was a team effort.
Congratulations, you guys
It was a
too.
team effort. Michael is in Georgia.
Yep.
Neil Erickson is in Hawaii. I'm here. And Dave is in Utah.
Utah, why did you get the Bay Bridge there?
So, you know, we had a lot of fun. And the really neat thing to me is these guys are damn good. They're just damn good, and they're just great to work with. And it made it a joy to do the project.
All righty.
Congratulations to you all.
Thank you, Jeff.
Yeah.
Does anybody need a break? All right, if everybody would like to have a seat, please.
Get this show on the road. It won't take very long.
Okay, so PowerPoint first or video?
PowerPoint first.
Okay, let's look up that.
Step back.
Okay,
So.
Click up toward.
all right, let's try again.
Yep.
Okay, so I know a lot of you and some of you don't know, but most of you I know actually, one way or another. A little personal background, first of all. Okay, I was like everybody, I started with American Flyer Set when I was a kid. Graduated into HO in high school when I was on paper route. My buddy was also a paper route guy. His dad had a HO layout in the basement, so we decided to build a little HO layout in my basement, high school, which was great until I went off to college. My mother said, layout's got to come out. So that was the end of my model railroading for about 20, 25 years. Other things got in the way, obviously. So college girls traveling around the country and being transferred. So, but got back into the Northwest, joined the National Model Railroad Association when I was living in Seattle, and then of course came down here. I've been involved with the 2D for a number of years, sat on the board for a number of years here. By the way, anybody who hasn't done that, it's a great opportunity now to join the board. I mean, the guys that you have are great. People we had before mostly were great. And but it's an opportunity to well, there's a couple of stories about that. Anyway. Okay, my current focus, I guess, is operations special interest group OPSIG. It's allowed me to operate on a number of the layouts locally, and it's also allowed me to operate on some regional layouts. The Ole Ops, the Sounder Ops, and we've got the Western Oregon operations session coming up in the 1st of June. So if you want to operate other people's layouts, it's a great opportunity. Mine's going to be actually open Thursday night, Saturday, and Sunday. So there's 3 different sessions on mine. Bill's got his open for a couple of days. There's some other guys who got theirs open as well. So it's a good thing there. So okay, let's go to the next one. Go to the next one. Okay. So a little bit about my current layout. When I moved into this house years ago, I built a small layout in one of the rooms. It was great, was fine. And then Walters came out with their first name train, the Empire Builder. And I used to ride the Empire Builder back to North Dakota all the time when I was a kid. So I had to have that. Well, it took, my layout was 20 inches or 22-inch radius. And so it had to be bigger. So that's how we started tearing out walls and making room outside this little bedroom into a bigger bedroom and into the pool table room and etc. So now it's about 2/3 of my basement for those of you who've been in it. Yeah, so we've run out of room there. But again, wanted to like say the other thing that happened is my nephew Dan moved up to Portland. He was with Portland. He went to locomotive engineering school. It's what he wanted to do. Ended up being a locomotive engineer on the Port of Tillamook Bay, and then ended up in the PNW when he moved to Portland. And then finally got on with BNSF. So he was a good model railroader, a former, brought a bunch of his former buddies and other railroad guys as well. And so that was the impetus to kind of move ahead. The layout itself, it's basically freelance. Cascade Deschutes came from the names Craig and Dan. We decided we couldn't call it Craig and Dan, so it seemed like Cascade Deschutes, and C&D came out that way. Pacific Northwest Railroading, again, with all the railroading guys that are involved, makes sense. I'm from Eugene originally, so SP, my nephew is very big into SP. I'm really more of a Great Northern Pacific guy, but you'll see a lot of SP and GN on the layout. So we built this railroad, kind of built it. I mean, we had the space and we got out a bunch of switches, a bunch of track, and knew what we wanted to do, understood all the basic planning concept and stuff. But unlike some other layouts that are represented in this room who have great plans and thought about it for years and years and years, this layout just happened. I mean, for the most part, as you can kind of see in there, we kind of fit the space. Started by removing a wall between the bedroom and the pool table room, made the first room bigger, and then we added more space after that. So, but it seems to work well anyway. Typical layout construction, L-girder benchwork, open grid benchwork, typical landforms. You know, I've been around a long time, so you started with cardboard strips and paper and that stuff, and graduated, matriculated into foam in some cases and stuff. But every kind of scenery kind of thing or construction thing that you can think of the last 30 years is probably represented in this layout underwear somewhere. So it is a double deck design. There are a few duck unders, but mostly once you're in the layout, once it's running, you don't have to worry about bumping your head too much. It does gradually climb. It starts out, there's enough track over the run that it just climbs out up to the top. So basically a Nolex. The original layout, original design did have a big helix at one end from the top to the bottom. As we got to the other room and added the other room, we removed that. So there's about over 400 feet of actually mainline track there as well. So we operate operations. Not something I thought about originally very much, but certainly has expanded and grown quite a bit. We're with the dispatcher. We have a train schedule with a 3-hour train schedule, basically. So the trains kind of mix and match and support each other as we go. We run turns out and back. We run manifests between, and we've got unit trains as well to kind of run through the layout and screw up everybody else as we're running along, keep the dispatcher happy. So track warrants, again, I have a number of actual railroaders that work on or come and operate on the layout. So we definitely have track warrants, and we have radios. So we have communications, and then the cars, typically car cards and waybill. Thought about doing other things, using NMRA or other kinds of different things, but at this point in time, car cards and waybills seem to be the best, seem to be most functional for everybody. So we have a lot of industries that support other industries on the layout. And then we have a lot of stuff that goes often on the layout as well. So, like I say, the original design was for 4 or 5 guys. So if you ever are down on the layout, you'll see there's some pinch points there that weren't going to be a problem when it was smaller. But when the room got added, when things got added to it, when it became a larger layout with 8 to 12 crew members, then it's sometimes you have to say excuse me every once in a while. So we do run 8 to 12. We have smaller people that run the layout as well as some of us older guys as well. So and we've got kind of 3 different rooms. We got the gray-haired guys, we've got the guys in their 20s and 30s, and then we've got a few the younger ones. Dan, my nephew here, he just had a second son. So the first son is 3. And is also already running a throttle and running trains and stuff. So we're kind of working on continuing the legacy, as it were. We do try and operate on a semi-regular basis. I'm not like Bill, who runs every first Sunday of every or first to Saturday of every month, but kind of wiggle it in and work it around and try and get 6 or 8 in operations a year. So basic layout logistics, 2 big classification yards, 2 staging yards, 1 at each end, obviously. And then there's a storage yard as well. And then for the switching, it's industrial, we've got some towns, and we've got a couple of branches. So if you want to run long trains from here to there, you can do that. If you want to run some switching, you can do that. If you're really into yard switching and yard master stuff, you can do that. So we use the NCD system, wireless throttles. There are some tethered throttles, mostly in the yards, typically because we don't have enough wireless throttles. But yeah, so it works out well for us. We kind of started that years ago. So anyway, there's a Facebook page if you want to know more. There are a bunch of things, but that's just kind of an introduction to it. Why don't you go ahead and we'll take a look at Dan's video and maybe get a little better visual of the layout itself. Any questions so far? Okay.
All HO scale, right?
HO scale.
I
Yeah.
mean, standard gauge, I should say, you have any narrow gauge on there?
No narrow gauge at this point in time. There's that thought process there. I had a G scale for quite a while after my base, you know.
Oh, you talked about it.
Yeah. So, but it got blown up and the tree got blown up. So,
All right, gonna try this.
The Cascade and Deschutes Railroad is a freelance HO model railroad developed by Craig and Dan Larson as an operating layout. The layout is loosely based on railroad operations in western Oregon and is heavily influenced by the Southern Pacific with a touch of the Burlington Northern. The general era is in the 1970s. The railroad is a point-to-point bridge line with 2 major classification and interchange yards, 2 staging yards at each end of the layout, and numerous towns and industries generate a wide variety of freight traffic along the main line. The layout is located in 2 connecting basement rooms. The original layout was built in a 16 by 40 foot room and then expanded with an additional 20 by 22 foot room. It's a double deck around the wall design with a center peninsula. The upper deck is reached by an ascending main line or NOLIX. There is over 400 feet of mainline track on the layout. The construction of the layout has been a continuous learning process, featuring a variety of standard modeling methods. Open grid benchwork with the plywood sub-roadbed topped with homosote or sheetrock is used for yards and large town areas. L-girder benchwork is also used for mountain and other areas as appropriate. The scenery base is formed with insulation foam or cardboard strips, heavy brown paper, and plaster gauze, with a top coat of Sculptamold, plaster, or drywall joint compound. The ground cover includes dirt, small stones, various ground foams, polyfiber, static grasses, and other commercial foliage products. Homegrown coniferous and deciduous trees are interspersed with a number of commercial products on the layout, with more being added on a regular basis. Additional detailed scenery, a homegrown train detection system for ABS, and ungraded structures are planned for the near future. Now let's take a ride up the Cascade and Deschutes subdivision. We'll start at Westport with a 6-track staging yard. As we continue on, you can see the 3 different elevations of the layout. This area will eventually become a grain elevator for Westport. As we round the corner, we enter West Lewiston Industrial Area. The area is home to 8 different industries and 28 different car spots. During a typical operation session, this area becomes extremely busy, and there are 2 different jobs that end up having to work this area. Let's take a moment and watch the SP-8369, a Westport to Easton manifest roll through West Lewiston. As we move out of West Lewiston, we enter Lewiston Yard. Lewiston Yard is home to 3 daily turns, the Niobe, Lipton, and West Lewiston, along with the BN and UP transfer trains. Lewiston has an 8-track classification yard, along with engine facilities and car repair shops. Lewiston also has a small intermodal ramp. As we move along the main line, our next stop is Niobe. It's a small town with 3 industries. Niobe is home to Fairview Mill, Kelly's Graphics, and the LG Distribution Center. Also, the branch line down to Larson Oil begins in Niobe. Diverging down the branch line, we reach Larson Oil. Larson Oil is a small-scale refinery which takes loaded oil cars in and then can redistribute them in many different commodities, including oil drums and boxcars. Continuing on to the next town is Lipton. Lipton is big enough for its own local based out of Lewiston Yard. It's home to 4 different industries: Kushner Asphalt Plant, a lumber yard, a cold storage, and a concrete transfer facility. As we move past the small town of Lipton, we reach Gateway Siding. Gateway has a small spur track at the east end. There are a few different agriculture-based companies here: a fertilizer distribution center, a local propane distribution center, and an equipment dealer. As we emerge from Tunnel 1, we enter Mill City. Mill City is home to a sawmill, a GP panel plant, and the prime metal pipe producer. As we pass Mill City, we encounter the steepest grades and rocky scenery as it climbs up the mountain. This is Kenton. Kenton is a major industry town. It's home to the American Paper Mill, but also includes 4 other smaller industries. It has a manufacturing plant, a lumber yard, a box factory, and also a propane distribution center. We have finally reached Summit Sighting. Summit is the highest point on the layout and about 68 inches above ground. As we begin down grade, we come upon a small forest fire. We are now passing Kyle Mine. Our unit cold train stages and loads out here. As we level out, we enter St. Marie Yard and pass the Joe Cax gravel pit. St. Marie is a switching yard and houses 6 tracks along with an arrival track and an engine facility. The yard is home to 3 different turns. The Mill City, Kenton, and East St. Marie turns all originate here. Eastbound and westbound trains stop here to drop off and pick up cars, along with the BN transfer. As we reach the east end of St. Marie, you can see the industrial district located here. The compact industrial area has plenty of activity and home to Heine Waste Management, Harris Reload Facility, Onic Manufacturing, and an oil facility, along with a distribution center. Leaving St. Marie, the main line winds through high mountain forests heading towards Jamestown. As we arrive at Jamestown, we reach the BN Junction. Jamestown is where 3 industries are served by the BN: the oil facility, a beverage distribution center, and a bakery. Jamestown is also home to a large co-op grain facility which loads our grain unit trains. Entering Easton Staging Yard, we conclude our tour of the Cascade and Deschutes subdivision. We're pleased to entertain visitors and Boomer Ops crews when we're able to. We do have a Facebook page which we update regularly and occasionally post videos onto our YouTube page as well. We hope you've enjoyed riding the rails with us, and we hope you had a good visit.
As I mentioned, my nephew's a bit of a foamer, so we got a lot of terrain right about it.
Great sound though, way to.
Yeah, he and his wife has a graphic design company, and they work together, and he enjoyed doing all that kind of stuff.
It's a great job. That's a great video.
Yeah, great, thanks.
Yeah.
So we will have the layout. I'll have the layout open later when I get back home. So for those of you not joining me tomorrow in operations,
Get there.
you're certainly welcome to stop by, take a wander around, after you get a feel for at least the layout. Again, I look at it as a stage 1 level of scenery. Every time I look at photos and magazines and stuff, I go, oh my God, I've got so much more to do there, and some stuff, here and there and all that kind of stuff. But it, for the most part, operates pretty well. And I have a number of people that enjoy doing that. So, yes, question.
One
Go ahead.
question, I see you're going, you go from one staging yard to the other, basically operating is point to point, or? do
That's
you,
correct.
Throw a couple of turnouts and step back and have a beer and watch it run and run?
No, actually, it can't. Well, that's not true, actually. There is a turn on at Easton, and there's another one down in the other staging yard, or in the other storage yard, but basically we run it, point to point.
Oh,
We have, manifest coming out of Westport up to West End, and dropping and picking up cars at the two major classification yards, and then ending up in Eastport at the top at the east end. So,
Great design.
yeah. So
What's
your maximum
Great trains you typically running in an op session, how many operators?
we can run, usually we will get about 14 or 16
Trains or operators?
trains. And usually I'm trying to step down, trying to stay between 8 and 12 operators simply because of the physical space. I mean, the bigger room is better. You can get around, but there's some parts of the first layout that are a little squeegee. So, yeah. So, but you've got, you've got manifests going around, you've got the turns going out and back. And then you've got unit trains. There's a coal unit train, there's a grain unit train, there's a Z train, there's a container train. There's a passenger train every once in a while. So when Stu comes over, he wants to run this passenger train. So
Can you set it builder?
yeah. The Empire builder, yeah.
What's your maximum grade then?
Actually, it was about 2.2%. We
Okay,
took the helix out and then changed. And so from as you come around the corner from the Mill City up to the what I call the Nolix area, and it got closer to about 2 3/4% in one little section. But basically, we're trying to keep it at 2% or so to meet that.
you run any passengers?
We do run. There's a Great Northern SPNS NP combination
Okay,
that in the old days that we run that's too. And then we every once in a while break out the Empire builder and we've also have Amtrak. And actually, when I was in Europe, I picked up a Talgo set, and so we also have a Talgo, although it's not painted for Cascades, it's blue. I picked that up in Spain, and so sometimes I run the Talgo set too. So yeah, it's freelance. It's it's my railroad or whoever's come. And we also entertain what people at Boomers or guys that come and bring some of their own locomotives that don't have space to run. We'll let them run their own locomotives and stuff as well. So we're kind of flexible.
What's your time frame?
Basically, most of the stuff is in the 80s, 70s, and 80s. But if you notice on there's some newer locomotives as well on there. Some of the BNSF, a few people have brought those on and got in there and stuff. I've got a couple of the GM stuff hanging around too. So and NP stuff. So it's not pure by any means.
Pure fun.
Yeah,
It
absolutely.
is a lot of fun to run. I've enjoyed it very much.
Yeah. It's one of our more seasoned operators.
Old might work too.
Yeah.
does that mean he's salty?
Yeah, yeah. Sometimes when he can't make the switches work. So there's a couple of switching things there are some people complain a little difficult, and of course my nephew being the railroader that he has made those so that it wasn't going to be easy. So the process is a different kind of thing. So
That's part of the trick.
If you want to, like I say, we operate 6-8 times a year. So if you have a feeling that you want to come and operate and play trains, we are certainly open to anybody that wants to do that.
Like a weeknight or weekend?
We're operating Sunday afternoons.
Sunday afternoon.
Usually the third Sunday afternoon, like operating tomorrow. Yeah. And the reason for that is that when we started, there was a lot of the railroad guys were working. A lot of the guys didn't have Saturdays off. A lot of times they did have Sundays off. So it kind of shifted into that Sunday thing. So, and the third weekend, first weekend is taken. Second weekend is usually taken. The fourth weekend is usually taken for operators in this part of the world from the different layouts and stuff. So
Decker, Comstock, Clackamas.
exactly.
I had fun trying to schedule these.
C&D kind of slides in there, and it works for us on this weekend because of because we're on Sunday, not Saturday, so,
You are in the opposite group?
yes,
Oh, that's all.
yeah. So
Okay,
I'm
you
one of
wanna
the
get
minor
your,
players.
And if you wanna get your dispatcher certificate from the NMRA, how I got mine.
Yeah, so, okay, any other questions? Yeah. Nope, yeah,
Address.
but,
If we want to
I
stop it.
got some maps.
Oh, okay.
Okay, I'll leave it in the back there. I think they're still in my pocket actually, but I'll leave some maps back there. So, but yeah, so it's really easy. I'm up by Washington Square area, so. So, it's, yeah,
Garden home area, right?
Garden Home, exactly right. Any other questions? Great, I appreciate the opportunity.
So gentlemen, I got a couple announcements for you and I didn't bring any information. Number one, I did a presentation online, I don't know, 2 years ago about the Cascade Deschutes restaurant.
Oh, yeah.
And the diorama we built, well, it's done and it is fine scale. And I don't say that bragging about anything, but it went from, Bachman track ballasted to a fine scale model railroad. Anyway, that's part of the thing. And then the other part is on May 7th is going to be the final run of the Mount Hood Model Engineers at 5500 Southeast Belmont. We have to be out of there by July. So we're looking for a new space and I probably would want to be on the 205 corridor and probably not in Multnomah County, but things are being looked at now. But anyway, if any of you want to come by May 7th, get hold of me. I'm jsparrows@yahoo, real easy to find. And we're going to have friends and family, so I'm going to call you family. You can come by and see us do running trains in circles, and then starting in probably the second weekend of May, we'll be packing it up.
I think the Fry's building over here is for lease.
But having said all this, which, I think put a few people in shock, we have a former member that has a container in Sherwood that's going to let us store our stuff, which will be a container full. And then what do we do with all the debris? We're going to take it up to his farm and put it in his pit and he's going to burn it. So we've got an exit plan. But what happens next? I don't know. But I've had a lot of people reach out to me. The Columbia Gorge says come over and run trains. The group down at Powerland says come down and run trains. And the Garden Railway people said join us. So my plate is full, but if you guys hear of any space, it's reasonable that we could rent, let me know. So that's all I got. I was going to do a presentation, but I think I'm going to expand on it. We'll work it in the schedule next time.
Okay, I think June is our next probable meet.
Okay, thanks.
Election coming up. We're electing a assistant superintendent. We have a candidate, Greg Baker, who two directors,
Two-year directors.
two-year directors. And that's Bob right here and John. And today, they just walked out. Today, we got a volunteer for the 1-year director that needed to be filled. And that's Gary Lee. And his assistant is going to be Warner. They just volunteered this afternoon. I was going to really thank them publicly for doing this. We still need a secretary. A volunteer for secretary.
You could still do this,
Let me get it all the thought deserves, no.
So anyway, so we have our candidates, the election, Geoff is gonna get information out to you, but we have our candidates now, thanks to Gary and Warner today.
Unless anybody else volunteers, it's gonna be by acclamation, and I'll just send out word to that on Monday.
So we don't need to give any write-ups and.
We don't need to spend any money on election software or anything like that.
Okay, but we now have our slate of candidates.
Okay, Sounds great.
As a committee of one, it was somewhat difficult.
Yeah, everybody gets the emails I'm sending out, right?
Yeah.
Because I had about the last one I sent out, I think had about a 56% open rate. So either people are not getting these or they just don't give a rip. And if you get a phone call, it's because you didn't open the last one, maybe. We're gonna start calling people, I think, saying, hey, are you getting these? Maybe we can get some emails updated or something. These, by the way, gift cards are for Tammy's Hobbies over by the Freddy's in Beaverton.
Hey, great Christmas stocking stuffers.
They have the best probable paint department
They have a good paint department.
in the area.
Yeah.
It's what I picked up 2 things of line wash and some yellow transparent paint today. Okay, green ticket, $29.78. And thank you all for coming.